we'll begin our class. So welcome to our class. And I have checked your homework for different process models and the diagrams. I have appreciated for your diagrams. But some of you have really copy paste directly the diagrams I put in the slides. And for others who have designed by yourself, who have drawn the diagrams by yourself, thank you very much, and really a good job. And for the homework, the corrections we can easily find in our slides. So I will not continue to show you the result. And if you have some questions, don't hesitate to contact me. And do you remember yesterday we have talked about the rational unified process? We have talked about this process via three perspectives. A dynamic perspective, which shows the phases of the model. A static perspective, which shows the process activities. And a practice perspective, which suggests good practices to be used. No person is there to answer me. We have also talked about the requirement for software systems nowadays. We say that the rapid development and delivery is now often the most critical requirement for software systems. And we have proposed a hybrid approach where agile methods incorporate the plan-driven and agile methods together. And do you remember how we balance between a plan-driven approach and an agile approach?
Lauschen.
Yeah, Kaya?
I think that in order for us to balance between a plan-driven approach and an agile approach, we need to ask the appropriate questions about how big the project is, and is there enough how much specification do we have? Do we have a lot of specification, or is there a bit of specification? And then I forgot the other two questions, but around those areas. So if it's a big project, then we would have a plan-driven approach. And then if it's a small project, we'll often have an agile approach. And also with specification, if it's very specified, then we can have a plan-driven approach because we have enough specification. If it isn't very specified, then we can use an agile approach because then we can integrate incremental development, which is part of the agile approach.
Great. Is that all?
Is that okay, Laoshi?
Okay, thank you very much, Kaya. Yeah, perfect answer. We have listed 10 questions yesterday, and Kaya has done a summary of these questions. And so we have to answer a range of technical, human, and organizational questions to balance between these two approaches. This is what we have talked about yesterday, and now we'll talk about the best known and most widely used agile methods, which is the extreme programming. Why we call it extreme programming? As we say, as the name implies, this approach was developed by it is known as iterative development to extreme. We develop it by pushing recognized good practices such as iterative development to extreme levels. For example, in this programming, we may have several new versions of our system. We may develop it by different programmers, integrated and tested in one day. That's why we call it extreme programming. We use an extreme approach to iterative development. And here is this figure illustrates the extreme programming process to reproduce an increment system. We see here in this cycle, at first we select user stories for this release. Then we break down stories into tasks. And we have the plan release later. After that, we develop, integrate, and test the software. After we release the software and evaluate the system, later we come back to select user stories for this release. Here we have some new words. For example, user story. What do you think of it? Can you guess its meaning? User story. What does it mean? Do you have some ideas about it here? User feedback. Roy and Amin have given like nightly builds of our software or daily builds by our build server. User feedback. Other propositions? Yeah.
I think a user story, isn't it the like a user will come up to a certain company and they would say what they want from the software, and then as engineers we'd have to break down their story. They basically explain what they want, and then we break it down into different components and we plan it. It is feedback, but I think the first cycle wouldn't necessarily be feedback. So I think it's just how what the software. I'm not sure.
So Kaya, you think still it's our feedback? Roy has several propositions: user demands and target demographic, and Malala said language description of features of software. Malala is a part of what Roy said, user demands. In fact, it's here, user stories. It means the requirements of users. It's like the specification. Here, in the extreme programming, we may call the requirements as scenarios or user stories. So we see here at first, we select the requirements for the current release. Then we break down these requirements into a series of tasks, and programmers work on these tasks, develop some tests for each task. Then we can release this software. Then release it and evaluate it. Later, we come back to select some user stories for the next release. In the extreme programming, we have something special. Here, all tests must be successfully executed when new code is integrated into the system. This is, so as we have said, here is the extreme programming release cycle. As we see here, we may involve some practices like the selection of requirements, breaking down these requirements into tasks, etc. Now we'll see these practices in detail. Here, for the extreme programming, we have at first the incremental planning. In this part, requirements are recorded on story cards. Story cards corresponds to the to user stories. That means where we write the specifications or requirements of customers. These stories are recorded. We have the requirements which are recorded on story cards, and the stories to be included in the release are determined by the time available and their relative priority. So we decide the requirements to be included in the current release, and we determine these things based on the time available and the priority of the requirements. And we see with the extreme programming, we have several small releases. That means the minimum useful set of functionality that provides business value is developed first. Here, as we use the incremental delivery, the releases of the system are frequent, and we incrementally add functionality to the first release. That's what it means here, small releases. Also, with this programming, it's the design is simple. We carry out enough design to meet the current requirements and no more. So the design is simple, not too complex for each release. Also, in this method, we have our practice, which is very special. It's the test first development. All developers are expected to test for a new piece of functionality before that functionality itself is implemented. That means normally we should at first test for the functionality to be added, and then we can implement the function. This function, we need always to at first write tests for a new piece of functionality. Then we can develop the this functionality. The next practice is the refactoring. All developers are expected to refactor the code continuously as soon as possible code improvements are found. In this way, we can keep the code simple and maintainable. The next practice in extreme programming is the pair programming. Here, developers work in pairs and they check each other's work. In this way, we can provide the support to always do a good job. Also, we have the collective ownership in extreme programming. The pairs of developers work on all areas of the system. That means all developers take responsibility for all of the code, and anyone can change anything of the code. Here is the collective ownership. We have also the continuous integration. As soon as the work on a task is complete, it is integrated into the whole system. After such an integration, all the unit tests in the system must pass. As we say, we should always test what we will add in the system. Then the next one is the sustainable pace. Large amounts of overtime are not considered acceptable. Here, because often overtime will reduce code quality and productivity. So normally in the extreme programming, we do not accept large amounts of overtime. An important feature in the extreme programming is the on-site customer. That means a representative of the customer should be available full-time for the use of the extreme programming team. Here, XP is the abbreviation for extreme programming. In an extreme programming process, the customer is a member of the development team, and the customer representative should bring system requirements to the team for implementation. So in this method, customer is strongly involved in the whole process. Through these practices, we see they reflect some principles of agile methods, like incremental development is supported through small, frequent system releases. We see that requirements are based on simple customer stories or scenarios, and we use these requirements as a basis to decide what functionality should be included in our system increment. That means different releases. Also, customer involvement is strongly in this method and in agile method, development process too. This involvement here, it means full-time customer engagement with the team. We have the continuous engagement of the customer in the development team in extreme programming, and the customer representative takes part in the development. He is also responsible for defining acceptance tests for the system. So really, customer representative is strongly involved in this method. People are supported by pair programming, collective ownership, and a process that avoids long working hours. This principle is reflected by several practices we have seen just then: pair programming, collective ownership, and over time, sustainable pace. Also, change supported through regular system releases. We see here, to cope with changes, we have regular system releases to customers, test first development, refactoring, and continuous integration of new functionality. Also, in extreme programming, like in other agile methods, we maintain simplicity through constant refactoring of code. In this way, we can improve code quality, and we can use simple designs that may anticipate future changes to the system. In our extreme programming process, customers, as we have said, are usually and strongly involved in specifying and prioritizing system requirements. Do you remember the two other names of requirements in extreme programming? For the requirements, we have two other names in this method, extreme programming. Do you remember the other two names? Do you remember? User stories, and another one? You forgot it? user stories and scenarios for requirements. Exactly, yeah. So here we say user requirements are expressed as scenarios or user stories. Together, the team members will develop a story card where we write these user requirements, and the development team break these requirements down into implementation tasks. These tasks are the basis of schedule and the cost estimates. That means we use these, how we break these requirements into tasks is depending on the schedule and the cost estimates. Then the customer chooses the stories for inclusion in the next release based on their priorities and the schedule estimates. To decide the requirements for the next release, we look at the priorities and the schedule estimates of each requirements. Here is an example of a story card for the mental health care patients management system. This is a short description of a scenario for the prescribing medication for a patient. In fact, in this prescribing, we see that we describe the requirements in detail, and these story cards are the main inputs to the extreme programming planning process. Once this story card had been developed, the development team breaks these requirements down into tasks. Like here, we give example of 3 tasks: change dose of prescribed drug, formulary selection, and dose checking. Then we estimate that the effort and the resources required for implementing each task. This usually involves discussions with the customer and to refine the requirements. The customer then prioritizes the stories for implementation, choosing those stories that can be used immediately to deliver useful business support. So it depends on the story card we make these tasks, and then we can decide what to put in each release. As we have said before, a fundamental precept of traditional software engineering is that we should design for change. We need to cope with changes. It's better to, what we have seen before is that it's better to anticipate future changes to the software and design it so that these changes can be easily implemented. As we have said before, we have several ways to reduce the cost of rework. And design for change is worth spending time and effort anticipating changes, as it reduces costs later in the life cycle. However, in our extreme programming, this idea or this principle has been discarded. It maintains that it is not worthwhile as changes cannot be reliably anticipated. For extreme programming, designing for change is often wasted effort. It isn't worth taking for extreme programming, it's not worth taking time to add generality to a program for coping with change. And the changes anticipated often never be realized, and completely different change requests actually be made. So, for the extreme programming approach, we accept that changes will happen and we will reorganize the software when these changes actually occur. Else, we do not think about it. Rather, the extreme programming proposes constant code improvement, or we can call it refactoring. In this way, we can make changes easier when we want to implement those changes. Now we'll see this refactoring in detail, how we refactor in our extreme programming. To refactor for the refactoring in extreme programming, the programming team look for possible software improvements and implement immediately. When our team member finds code that for example, one team member finds that the code can be improved, then all the team will make these improvements immediately, even that there is no immediate need for these improvements. And this will improve the understandability of the software and also reduce the need for documentation. Also, as we have said before, changes will be easier to make in this way, as the code is well structured and clear. However, the constant refactoring can be convenient in some cases, but not all cases, as some changes require architecture refactoring, and this will be much more expensive. Now we'll see what kind of changes can be constantly refactoring. We may reorganize our class hierarchy to remove duplicate code. We may also tidy up and rename attributes and methods to make them easier to understand. Also, the replacement of inline code with calls to methods that have been included in a program library. In fact, for some programming languages like Java, we may have some program development environments like Eclipse. There, we include tools for refactoring, and in this way, we can simplify the process of finding dependencies between code sections and making global code modifications. Do you have some questions still here? If you don't give some questions, we'll continue. else, I'll ask you some questions to see if you have some ideas about what we have seen till now. The first question, why we call this method as extreme programming? Why we call it extreme programming? Because it will always be changing, because the methods are quite hasty. It's a continuous cycle of changes. Yeah. Yeah. Really, it is an extreme level to put the iterative development into the extreme, really extreme. As we have explained before, we may have several new versions tested in one day, delivered in one day, changing always, as Hosan says. Yeah. Yeah, this is the characteristics of extreme programming. And do you remember the extreme programming release cycle? Yeah. The extreme programming release cycle. Can you describe it, please? User stories. Yeah. We at first we choose the user stories for the current release, and then we break it down into different tasks. User demand task division, plan release, test release, final release, back to user demand. Yeah, nearly it's nearly completely. Yeah. At first we select the user stories, like you said, user demands or specification or requirements for the current release. Then we break down these requirements into tasks. Later, we plan the release and develop, integrate, test the software. Then we can release the software and evaluate the system. At the end, we come back to select user stories for the next release. Yeah. Okay. So for this part, it's okay. And then we have talked about different practices and principles of extreme programming. Yeah, what is important here is also to see these principles. Yeah, these principles. We have incremental development, which is supported through small frequent system releases. We have, as we see that customer involvement means full-time customer engagement with the team. That means customer is strongly involved in the process, and people are supported by pair programming, collective ownership, and a process that avoids long working hours. Yeah, this part is also this principle is shown by many practices. Then we change supported through regular system releases. Then we maintain simplicity. We maintain the system simplicity through constant refactoring of code. Yeah, these principles, it's better to keep it in mind. Okay, for this part, it's okay. Yeah, that's why we say to cope with changes in extreme programming. It's not, this principle is not so important with as we have the refactoring, constant refactoring of the code. And the refactoring, it depends on some situations. We have some examples of refactoring where we can have the we can continuously refactor. Now we'll see one of the most important innovatives in extreme programming. It is the testing. Also, testing is one of the important differences between incremental development and plan-driven development. As we say that with incremental development, there is no system specification that can be used by an external testing team to develop system tests. So some approaches to incremental development have a very informal testing process, especially compared with the plan-driven testing. And to avoid some problems of testing and system validation, here the extreme programming has developed an approach where the program is tested after every change has been made. In this way, we can reduce the possibility of introducing undiscovered errors into the current version of the system. The extreme programming testing has 4 features. The first one is the test-first development. Second one is the incremental test development from scenarios. And then we have user involvement in test development and validation, use of automated testing frameworks. We'll talk about these 4 features in detail. But at first, keep in mind that this testing is a very important part of extreme programming. Yeah, let's have a break of 10 minutes, please. Extreme and agile. Oh, you have sent a message. I'm sorry. Extreme and agile nearly same. Okay. No, it's not. Where project is not big. If project refactor extreme programming or standard at first here nearly the same. It's not nearly the same. It's extreme programming. It's one of the agile methods, and it is the most known and mostly recognized. We can say it is the best known and widely used agile methods. Later, for your algo here, where project is not big. If project needs, we need constantly refactoring, then we use extreme programming, else standard agile programming. It's not here. This part is not really like this, because for the extreme programming we have other characteristics, not just for the refactoring. Roy, here. Yeah, because for the extreme programming, we'll see later, we have different innovatives of the extreme programming. The testing is one innovatives, and we have other things. We'll talk about it in the I think in the next class, or in 10 minutes. But it's you are right. When the project is normally when the project is not very big, we use agile approach. And as extreme programming is one method of the agile approach. In some situations, we can choose it. We'll see how to. Later, we'll see in which situations we have this. It's better to use this method. Okay, have a break of 10 minutes, please. And now we'll continue with our testing in extreme programming. Now we'll see these 4 features of extreme programming testing in detail. The first one is the test-first development. Test-first development is one of the most important innovations in extreme programming. In this development, we write tests before code, and we clarify the requirements to be writing tests before code clarifies the requirements to be implemented. That means we need to write tests before coding, and this way we can clarify the requirements to be implemented. Instead of writing some code and then writing some tests for that code, in extreme programming, we write the tests before we write the code. And it means that we can run the test as the code is being written and discover problems during development. Here, tests are written as programs rather than data so that we can execute these tests automatically. Writing tests implicitly defines both an interface and a specification of behavior for the functionality being developed. All previous and new tests are run automatically when new functionality is added, thus checking that the new functionality has not introduced errors. As we've seen before, when we want to add some functionalities, we should always test it. Ensure that new functionality will not introduce errors. And this figure is a shortened description of a test case that has been developed to check that the prescribed dose of a drug does not fall outside known safe limits. It's our previous example. We see in this test case description, we have the input as a customer, a number to represent a single dose of the drug, a number to represent the number of single doses each day. And we have 4 situations to test. We test for inputs where the single dose is correct, but the frequency is too high. We test for inputs where the single dose is too high and too low. We test for inputs where the single dose multiplies by frequency is too high and too low. Also, we test for inputs where single dose multiplies by frequency is in the permitted range. Output OK or error message indicating that the dose is outside the safe range. That means normally for these 4 situations, we will have the output OK for this one. The others will have some error message to indicate that the dose is outside the safe range. Is it clear for this test case description? Now we'll see, as we have seen that we have discussed before that for extreme programming, customers are strongly involved. This process, the testing process, it also involves it's also involved by the customer. We see the role of the customer in the testing process is to help develop acceptance tests for the stories that are to be implemented in the next release of the system. And in extreme programming, acceptance testing is like development. It is incremental. And the customer who is a part of the team writes tests as development process. So it's a incremental process. And all new code is therefore validated to ensure that it is what the customer needs. However, people adopting the customer role have limited time available and so cannot work full-time with the development team. We see sometimes it will be very difficult to rely on the customer to support acceptance test development. What else? The customer sometimes may feel that it is already enough to provide the requirements, and maybe it is reluctant to get involved in the process of testing. Yeah. In the process of testing, we have the test automation. It is essential for the test first development. Test automation means that tests are written as executable components before the task is implemented. As we said before, before coding, we need an executable test. Here, we simulate the submission of input to be tested, and we check that the result, if the result meets the output specification or not. Just like what we have seen our example. The first situation, we have the corresponding output. An automated test framework will make it easy to write executable tests and submit a set of tests for execution. Here, JUnit is widely used as an example of an automated testing framework. As testing is automated, there is always a set of tests that can be quickly and easily executed. So when we want to add any functionality to the system, we run the tests and catch problems that the new code may introduce. This is the function of the automated the test automation. In fact, test first development and automated testing usually needs a large number of tests which has been written and executed. However, this approach does not necessarily lead to thorough program testing. And we have here we have several difficulties of extreme programming testing. The first one is that programmers prefer programming to testing, and sometimes they take shortcuts when writing tests. For example, programmers may write incomplete tests that do not check for all possible exceptions that may occur. So in this situation, we may have some bugs when we deliver the system. The second difficulty is that some tests can be very difficult to write incrementally. For example, in a complex user interface, it is often difficult to write unit tests for the code that implements the display logic and the workflow between screens. As we say, with the extreme programming, like other incremental programming, we program incrementally, and here some tests may be very difficult to write incrementally. Also, it may be difficult to judge the completeness of a set of tests. Although we may have a lot of system tests, our test set may not provide complete coverage. That means even crucial parts of the system, we have some of them, but we may not execute all crucial parts of the system so that some parts will remain untested. Therefore, although a large set of frequently executed tests may give us ideas that the system is complete and correct. In fact, this may not the case. If the tests are not reviewed and further tests written after development, we may deliver some undetected bugs in the system release. Yeah, this part is for the extreme programming testing. Now we'll see another innovative practices of extreme programming, which is the pair programming. In extreme programming, programmers work in pairs. They actually sit together at the same workstation and they develop the software system. This will help even develop common ownership of code and spread knowledge across the team. So this is an advantage of pair programming. We can support the idea of collective ownership and responsibility for the system. As we say that with this way, the software is owned by the system, by the team as a whole, and individuals are not held responsible for problems with the code. And instead, the team has a collective responsibility for resolving these problems. The second advantage of pair programming is that it serves as an informal review process as each line of code is looked at by more than one person. As with our experience, we see that making mistakes in code is very usual, and code inspections and reviews are very successful in discovering software errors. Although pair programming is a less formal process, and we may probably can't find as many errors as code inspections. But pair programming is a much cheaper inspection process than formal program inspections. Another advantage of pair programming is that It encourages refactoring as the whole team can benefit from this. As we say, refactoring is important in extreme programming, as mentioned by Roy too. It is a process of software improvement. An individual who practices refactoring may be judged to be less efficient than one who simply carries on developing code. It's like a norm that people who refactor is not as efficient as people who develop the code. But in fact, it's not usually true. And in this extreme programming, we have the pair programming. And the pair programming and collective, when we use pair programming and collective ownership, others benefit immediately from the refactoring. So people or programmers are likely to support this refactoring process. Okay, now we'll see, we'll review the characteristics of pair programming. In pair programming, programmers sit together at the same workstation to develop the software. Pairs are created dynamically so that all team members work with each other during the development process. That means, yeah, we may have a different partner in different period. Also, the sharing of knowledge that happens during pair programming is very important as it reduces the overall risk to our project where team members leaves. When our team member leaves, yeah, you see, as we say in agile methods, documentations are not so complete. With pair programming, as all members share the knowledge of the system, if one member leaves the team, others will have more possibility to keep the original idea of the system. Pair programming is not necessarily inefficient, and there is evidence that a pair working together is more efficient than two programmers working separately. Yeah, as in the daily life, we might think that pair programming is less efficient than individual programming. But in fact, there have been various studies of the productivity, and they found that productivity with the pair programming seems to be comparable with that of two people working independently. The reasons suggested in these studies say that pairs discuss the software before development. So probably they will have fewer false starts and less rework. What's more, the number of errors avoided by the informal inspection can save more time than repairing bugs discovered during the testing process. So pair programming is efficient in some way. We'll review the advantages of pair programming. It can support the idea of collective ownership and responsibility for the system. It acts as an informal review process because each line of code is looked at by at least two people. It helps support refactoring, which is a process of software improvement. Yeah, till here we have introduced the pair programming and the testing extreme programming. These are two fundamental features of extreme programming. So for the question of Roy, yeah, when the system is not large, not just with refactoring, the requirements of refactoring that we use extreme programming, we may choose extreme programming with other reasons. For example, the testing or pair working, etc. And do you have some questions still here for this part? For the extreme programming, do you have some questions or doubts? No? Okay, thank you, Armin. So we'll continue with the next section, the Agile project management. How do we manage Agile project? The principal responsibility of software project managers is to manage the project so that the software is delivered on time and within the planned budget for the project. Here, the managers supervise the work of software engineers and they monitor how well the software development is progressing. The standard approach to project management is plan-driven. Yeah. As managers can draw up a plan for the project to show what should be delivered, when it should be delivered, who will work on the development of the project deliverable. Also, a plan-driven approach really requires a manager to have a stable view of everything that has to be developed and the development processes. However, with our agile methods, we cannot work in this way where the requirements are developed incrementally. The software is delivered in short, rapid increments, and changes to the requirements and software are quite usual. So with agile projects, we need a different approach, which is adapted to incremental development and the particular strengths of agile methods. To solve this, we propose a SCRUM approach, which is a general agile method, but its focus is on managing iterative development rather than specific agile practices. We have 3 phases in SCRUM. Here, this figure shows the SCRUM process. We see that in this process, we do not prescribe the use of programming practices such as pair programming and test-first development. Here, in this SCRUM process, the 3 phases are composed by the first one is a outline planning phase where we establish the general objectives of the project and we design the software architecture. Then we have a series of sprint cycles. Here, in each cycle, we develop an increment of the system. You see, we have the assessment phase where we assess the objectives, the requirements. Later, we select the requirements to be included in the current release. We develop the system, we review it, and then we continue to assess the requirements. Finally, we have the project closure phase, where we wraps up the project and we complete required documentation, such as system help frames and user manuals. Also, we can assess the lessons learned from the project. At first, we'll review these three phases. We have the initial phase, which is the outline planning and architectural design, the sprint cycle, and the project closure. These are three phases in Scrum. Here, the innovative feature of Scrum is this central phase, this one. We call it sprint cycles. A Scrum sprint is a planning unit in which we assess the work to be done. Here, we assess the work to be done. We select features for the to develop and the system to implement. So we develop and review the system. At the end of a sprint, the completed functionality is delivered to stakeholders and will come back to assess the work to be done. Have I answered your question, Roy? For the cycle? Yeah, okay, thank you. Yeah. How to exit? How to exit this cycle? When all the requirements are executed, all the requirements are included in the system, then we execute to closure to the project closure. So now we'll continue. In fact, for this sprint cycle, we have several key characteristics. Okay, I will see if this one. Yeah, the first key characteristics of this process, this sprint cycle, is that sprints are fixed lengths. And normally it's from 2 weeks to 4 weeks. This period corresponds also to the development of a release of the system in extreme programming. And the second feature is that the starting point for planning is the product backlog, which is the list of work to be done on the project. As we have seen in the cycle, we begin by the assessment phase, and here, in the assessment phase, the list of work to be done is reviewed, and priorities and risks are assigned. As we say that the customer is closely involved in this process, and the customer can introduce new requirements or tasks at the beginning of each sprint. That's why we begin by the assessment. And we need to assess for the list of work to be done. We should keep in mind for the product backlog. Later, for the selection phase, it involves all the project team to select the features and functionality to be developed during the sprint. And once these phases are agreed, the team organizes themselves to develop the software. Here, during this stage, the team or the developers, programmers, they are separated from the customer and the organization. All communications will be through the so-called Scrum Master. And the role of Scrum Master is to protect the developed team from external distractions, because the programmers will organize themselves to develop the software. So when customers need to communicate about the requirements or something else, they will communicate through Scrum Master. And at the end of the sprint, the work done is reviewed and presented to stakeholders. Later, the next sprint cycle will begin. Here, if there are some other requirements, we will assess these requirements again. That's this cycle. We see that the idea behind Scrum is that the whole team should work together to make decisions. So teamwork in Scrum is very important. Here we have mentioned a role, the Scrum Master. In fact, it is a facilitator who arranges daily meetings, checks the backlog of work to be done, records decisions, measures progress against the backlog, and communicates with customers and management outside of the team. Here, with the in the Scrum, the whole team attends short daily meetings where all team members share information, describe their progress since the last meeting, problems that have arisen, and what is planned for the following day. This one, it means that everyone on the team can know what is going on, and if there are some problem arising, then members can replan short-term work to cope with the arisen problems. Everyone participates in this short-term planning, and there is no top-down direction from the Scrum Master. Like we can say, there's no manager. So yeah, the notion of managers. For the Scrum, we have several advantages. As we see, the product in Scrum is broken down into a set of manageable and understandable chunks. Unstable requirements do not hold up progress. The whole team have visibility of everything, and consequently, team communication is improved. Yeah, this is the advantage of teamwork. And these two describes also the incremental development. Customers see on-time delivery of increments and gain feedback on how the product works. Yeah, as we have incremental development, we may have the delivery rapidly, and we can give the feedback also on time. Another advantage of Scrum is that trust between customers and developers is established, and a positive culture is created in which everyone expects the project to succeed. as we say that here customers are strongly involved, and then communications will be frequent, and we can establish trust and confidence on each other. In this way, we can create some common ideas, like we all want the project to be succeed. Okay, this part is to introduce the management of agile project, and we have talked about the Scrum. The Scrum is a general agile method. We'll stop here for today.